Hey guys, welcome to the video. So in this video, I will, this is something which a lot of people I have heard from my peers, colleagues, and people that typing equations in MS Word is very difficult. This is a very general perception that people have, and yeah, I get it. So I like to use Word because I find it very easy. Even when your document might contain a lot of equations and stuff, the only place where MS Word is not very good is maybe the formatting, and that's the reason. Of course, I'm not asking you to avoid LaTeX and start using Word, because LaTeX is the most standard. Like the it's the for scientific documents, LaTeX is the most accepted one. So I'm not saying you should avoid LaTeX, but just as an alternative, or maybe if you still don't know how to use LaTeX, I just want to show you in this video that even in MS Word, if you know a little bit of tricks, typing equations, even complex equations, can be easy. So I just want to show you this, but I'm not saying that Word is better than LaTeX, or you should use Word, you should not use LaTeX. Not that even I use LaTeX, but sometimes, especially for my unofficial reports or something, I still prefer Word over LaTeX, because I, for instance, if I'm being very honest with you, I don't find LaTeX very intuitive, and Word is not very difficult when it comes to equations, in my experience. I have most of my documents up to this point, like my internship reports, my articles, 70 pages, 80 pages, full of equations. I have used Word. So let me just see if I can convince you. So here we have a document, and this is I'm using the MS Word. I think the latest version of Word. So anyway, it doesn't matter. This is Windows. I think this is Windows 11 or Windows 10 maybe. Not sure. No, this is my new. Okay, this is, I think this is Windows 11. Anyway, doesn't matter. So these tricks are more or less should work on if you have a decent updated version of Word, not something like the oldest version of Word, of course. Something. So suppose I want to type a very simple equation. First of all, first things first, let's say you want to type F equals MA. So you can do this. Okay, let me just, that's better. But how to type equations in Word? First of all, you can do the old way, like you can do the conventional way. You can go to insert, you can go to equation, and then you can type F equals MA. Now this looks good. And by default, equations are center aligned, as you can see. You can make it left aligned if you want. If you want, you can just Control plus L and it becomes left aligned. But usually it's center aligned. But you don't need to do all of this. The way you can do it is that you just press alt plus okay, I'll just show you. I'll just type it for you. Just press the alt key on your keyboard, and you just press and hold alt, and then you press this key, which is, I don't know, there's a key at the top which has plus as well as equal to. So both of these symbols, I'll just let you figure it out. But usually in most Windows desktops, I mean, this is, I'm not sure. I can check right now if you want. Yeah, for instance, in my MacBook, there is no such symbol. Oh no, even in the MacBook there is a symbol like this. Yeah, it's true. So even in the MacBook, so you have the, at the top of your keypad, you have 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0. After 0, you have this minus and the dash or the hyphen, and after that you have this key. So this is the key I'm talking about. So if you press both these keys together, ALT plus that, then you automatically have this equation format. You don't need to go to insert and click press equation. So for instance, you have nothing. Let's say you have nothing. You just press Alt and this key, and you have this, and now you just type an equation. So now we know how to call this function, like how to get this without having to, like, just using your keys on your keyboard, how to get here type equation. But now you, let's say you want to type a very complex equation, not something like F equals MA. Okay, maybe you want to type an let's say an integral. So let's say you want to type something like, okay, let's see. Let's say integral minus infinity to plus infinity. Okay, so for integral, I'm not sure if this is gonna work. It doesn't work. Okay, fine. I'm kind of improvising. So you always have this option. Okay, once you have type equation, you have this equation tab which will appear, and in the equation tab, of course, you have integral here, and you have everything here. Like if you want just this, or if you want to put limits, if it's a double integral, if it's a triple integral, if it's a closed integral, you have all this stuff. But that's fine. I mean, I was just trying to figure out. Let's say you do int. Yeah, okay. So this is it. So usually this is a general trick. Whenever you want to, like, maybe whether it's an integral, it's a summation, whatever. Start with a backslash. So this backslash. Then int is for integral. Now if I and after this, if you just press the space bar on your keyboard, space bar, automatically it becomes an integral. So you don't need to like go to any tab or use the touchpad, use your cursor, use your nothing, just the keys you're using. And once you do a little bit of practice, this thing actually becomes very easy and spontaneous. You don't need to write codes and render it everything like you do in Overleaf or LaTeX. But for instance, you want to put limits to the integral, so you just give the backspace int, but don't press the space bar. Give an underscore. Okay. It automatically takes integral. Let's see if this works. Underscore a. Yeah. You see it works. So int underscore a, and then you give the x this to the power symbol, this symbol b. So automatically the underscore means the lower limit, and if you give the to the power, it's the upper limit. And the general rule is always you give the underscore first, the lower limit first, and then the upper limit. Let's say you want to do something like summation. So it's a capital sigma. So just backslash s capital igma. If you do this sigma sigma but s small, then it will give you the sigma symbol, the Greek symbol, this one. Okay, it will give you this one. But this is not what, this is the symbol sigma, right? But this is not what you want. If you want a summation, you start with a capital S sigma, you get this. Now let's say you want I equals 1 to n. So sorry, underscore I equals 1. This doesn't work. That's why I wanted to show you. So if you give underscore, and if it's a single, let's say if it's just a single letter or a single number, just I, and then it's fine. But if it's something like underscore I equals 1, so you better use the second brackets. Okay, so whatever you're putting in the second brackets is being treated to be in the subscript. So I equals 1. Let's see what happens now. So you see, okay, I'm sorry, this doesn't work because the second bracket is also showing. So you just have to, I'll show you another trick. Just write sigma underscore I, just give a space bar, it happens. Now you give the left arrow, the arrow you use. For instance, if I suppose urban, so let's say I'm here, my cursor is here, and if I want to go back, go left, so I use the left arrow, right? I do this. Similarly, once you are here, you just use the left arrow, and then it will automatically go to the subscript. You see this I becomes shaded, and now you write equal to 1, and that's fine. Then you again press the right arrow, you will come here, and now you give this n. Okay, so now you have summation I equals 1 to n. Now, this doesn't look good, so if you want it to look good, then I'm afraid you have to use this. You just use this large operator, and you have this. Yeah, so then you have this, so you have a very big symbol. But if you just want to type it out, then it's the same thing. It means the same thing, but it appears like this, as you can see. It appears like this. Okay. So you know how to type summation, how to type integrals. For fractions, you don't need to worry. Just a by b, and just give the space. It automatically becomes fraction. If you have a very complex fraction, like maybe a lot of stuff in the numerator, so you don't have. If you do, suppose, let me just show you. Suppose what you want is actually a plus b plus c by 2. This is what you want. So that means you always start with the bracket because your numerator have more than one term. So otherwise, what's going to happen is a plus b plus c by 2. So this is going to happen, which you don't want, right? Or you can, and if it's a very complicated sum, like fractions in the numerator, you have a lot of complicated terms. So you just write a over b and give a space. Now you come to the denominator and just edit it. Whatever you have to write here, just do it manually after you. Whatever, I'm just an example, and then you do it the numerator. So if you do a over, I mean a slash b and space, so you just create a fraction, and then you can edit the denominator and the numerator, right? So these are a few tricks you can use. Okay, and I'm going to show you something else as well for symbols. Okay, so for symbols, usually you can take this symbol, and like for instance, you want, this is the bracket. Okay, so if you want to type in something in quantum mechanics, so you go to the symbol. I'm sorry, I think I just need to pin this. How to pin this? I forgot. Oh, full screen mode. Oh no, I'm sorry. Always show ribbon. Yeah, it's fine. So let's say so you go here and you go to the symbol. Symbol is just under the insert tab before equation, below equation. So let's say you have shy here, then you want this thing, and then you have another shy here. Okay, so let's say you have shy f, which is shy final, and you have shy I, which is shy initial, and then you want to close this symbol. So this is very this is not very convenient, right? You have to go to this symbol and have to type everything. So but you can do it even without having to do all this, just using your keyboard. Let me show you how. So for bracket notation, I've never, yeah. So for bracket notation, just start with the backslash and type in bra, and this happens. For get, you do the same thing. It happens. Okay, good. For shy, again, backslash psi, you get shy. If you want a capital shy, I'm not sure if such a thing exists, but if you want a capital shy, oh, yeah, this is the capital shy. Shy I, so everything works. So for Greek symbols, for any symbols, you just backslash and type it in theta. Okay, so this is theta, capital theta, T capital. This is capital theta. Everything works. You just need to, for instance, lambda. I'm sorry. So this is, I understand this might be a bit inconvenient because you have to spell it out. But trust me, if you're a fast typer, it's often it's I mean it's not very difficult actually. You can type everything. Like I showed you a couple of things. Now I'm gonna, for instance, if you're a physics student, you may have to write the reduced Planck's constant a lot of times, h bar. So there's a very good trick. You just backslash h bar. So automatically it happens. You don't need to find the symbol every time, and you can just with a bit of practice, it's very easy. So now I'm gonna show you. Okay, let's type some complex equations just to show you some tricks, just to illustrate, and some for practice maybe. I don't know. Okay, let's start with the classic Schrodinger's equation. So you have minus h bar. Okay, so you have negative h bar squared over 2m. Okay, so now you have the Laplacian operator. So that's actually nabla, right? So nabla, n capital. Okay, I think this works. This doesn't work. Okay, so you have to write the n small because there is some nothing called capital nabla. Yeah, that doesn't make sense. So then squared psi. So this is psi plus v psi equals I h bar. Okay, this is important. So here we have a partial derivative, partial time derivative, del psi del t. So how do you type del? It's not like if you do this, then you have d psi. Then you have, sorry, then you have this thing d psi dt. But this is not what you want. You want del psi del t, right? So for I h bar. Okay. So first of all, let me just write it in fraction form, and then let me write it here because this looks good. So I h bar. So you want a del psi del t. So for del, you just write backslash partial, just partial, nothing else, just partial, because partial means automatically it will take partial derivative, and to give the space, see, it's del psi, and then here again you write in partial. So here we have Schrodinger's equation. Let's see, want to write some limit. Okay, so limit n tends to infinity. Okay, so limit. Okay, I'm sorry. Limit, to give the underscore, and then you write, let's say n. Okay, yeah, this works actually. So limit underscore. I'm sorry. Limit limit. So see, you have to give the backslash. If I just write limit underscore n, oh, even that works. Good, good. Limit underscore n. Just give the space, and you come here, and now you want the right arrow. So you can try. Let me try, but I'm not sure this will work. You just give the hyphen, and you give the this greater than symbol. Oh, it works. Oh my god, I'm actually surprised. You give the hyphen and you give the greater than symbol. It automatically takes the right arrow. You see what I'm doing? I'm just doing this and this, but it automatically takes the right arrow because it's clever enough to figure out that under the limit I can mean only this. So let's say limit n tends to infinity. So for infinity you have backslash infty. You don't need to memorize all of this, but with a bit of practice, this will automatically get this will become be part of your memory. So for infinity, it's just infty, not infnity, not this, just infty. You see, it's infinite. If you just do inf, it doesn't work. So it's infty, and then you write whatever you want to write here, the limit or whatever. So even limits can be done. So we covered summations, limits, integrals. For square root, it's a bit complicated because you can sqrt doesn't work. Oh, sorry, I s capital. So sqrt works, but it's like this. So for instance, write something in the square root. So let's say square root x square plus y square doesn't look good because you understand what I'm saying. So for this, what you actually want is, if you use this here under the equation tab, you have this radical. You do this, and now you write x square plus y square. So it looks good because the entire square root is covering this entire thing. If you just do this sqrt and if you do this x square, you see the problem. It doesn't cover that. I'm not sure how to. There may be a way around this. I've not tried it. I'm not sure yet. So yeah, more or less everything. If you let me show you some other stuff as well. What else can I show you? Yeah, I mean, if you want to write some complex equations, tell me about some other equation except the Schrodinger's equation. For instance, let's say you want to write. I mean, let's say you want to write the equation for Kuramoto oscillators, coupled oscillators following the Kuramoto synchronized oscillators, right? So you have d theta I, so theta underscore I over dt, which is equal to, let's say, omega I. So yeah, if I used a small o, so that's gonna give me this symbol. If I use this thing, I would have gotten the capital omega, of course. So this is omega I plus, let's say, k over k, small ki. Okay, and then we have summation. Okay, j sigma j sine. So if you just write sin and to give the brackets, automatically it becomes it takes the sine function. So you will understand that you're talking about the sine function. Theta j minus theta I. So I mean, these kind of equations you can easily take care of in MS Word, no matter whatever. I mean, and if your equation is very complicated, I mean, even if you're using LaTeX, you have to bear some go through some effort, right? It doesn't come. I mean, if the equation is very complicated, then LaTeX only gives you a slight advantage. It's not like LaTeX types the equation for yourself. You have to type it. I mean, the formatting and stuff, that is where LaTeX wins, because it doesn't have to go through all this, like in Word you have to do the formatting part, but otherwise typing equations in Word is difficult. People usually say, not really, if you know how to know the tricks. Not like it's not exceptionally difficult or anything. For instance, you want to write something like I don't know, let's say Kronecker delta. So use this small delta, so it becomes like this delta ij. If you just want to write capital delta, of course you get this triangle. If you want to write, okay, so let's say you want to write proportionality. So let's say, I don't know, you want to write the energy is proportional to temperature or something like this, whatever. I mean, let's say you want to write y proportional to x. So instead of searching for the proportional symbol, I'm sure you'll find the symbol somewhere here, but you don't need to actually. Yeah, so this is the proportional symbol, but what you can do is you just backslash prop2, PROPTO. So this means proportional. Don't you give the space. Oh, I'm sorry. Backslash prop2. Why doesn't this work? Oh, I was using the front slash, I think. I guess prop 2. Yeah. So y prop 2 x. This means y is proportional to x. Right? Let's say you want to give, I don't know, not equal to. So not equal to is very simple. Just backslash neq. Eq is equal to, neq means not equal to. You see not equal to. So let's say a not equal to b. So you just type in a backslash neq b, space b. So a not equals to b. What is EQR? It doesn't work. I mean, of course, there is an equal to symbol on your keyboard, so you won't type backslash EQ for equal to, but for not equal to, it's backslash NEQ. Let's even type something. Okay, so for plus minus, okay, let's say x is greater than. Okay, so for greater than equal to, just type the greater than and then type equal to. It will just, so on your keyboard you just press the greater than key and you press the equal to key. It will automatically take greater than equal to. If you're in equation format, like if you're normal typing, what I did was this, but in equation format, if you type, if you press those same keys in order, it will take this. That's what I meant. So let's say you want to do not equal to greater than equal to. Let's say you want to do, I don't know, something like okay, plus minus. So again you just press plus and the minus in succession, it happens. Let's say you press minus, you press plus, it's minus plus. It's all kind of automatic. So that's why I'm saying Word is actually pretty good. Cube root. Okay, so for cube root, I'm not really sure how to do it. SQRT is the standard for square root. Now for root, for radical, I'm just trying randomly, but I'm not really sure. But for, yeah, so there is cube root, there is fourth root. For you can use the radical symbol to get this general form, and you can have any nth root here. but I'm not sure about what is the general code for this. Might there could be some keyboard shortcut also for this. I mean, maybe there is, definitely is. Now for matrix, I'm not sure how to, like, you just I think the best way is to just use this. You can generate matrices here. It's 2 by 2, 3 by 3. There are a lot of options. Matrices with brackets, stuff, sparse matrices. You can generate this. It's already a lot of ready-made. Just, you can do this and you can fill them in by hand, like A, B, and blah blah blah. Okay, and what else? Any other complex equation you want to type, that you can think of? I mean, okay, first is vector. This is very important. So if you, it's first time I want to type x vector, or let's say v vector velocity. So you always have this accent option, and you can just there is an arrow on the top. I'm pretty sure somewhere here. Okay, yeah. So this is the arrow. If you just do this, and so automatically this will be generated, and you just type v here. So this is v vector. But if you want to do it by hand, again, I'm not sure what works here actually. Okay, v. Okay, this doesn't work. Okay, of course. I'm sorry. Okay, so A, if I just select it, and okay, I think for this the best way is to use the accept, because I've not tried, but definitely there could be other ways also. I've not tried, but you could try it out. But I know, see, the point of this video was to give you an introduction of how you can use these little tricks and techniques. But once you start using them with a little bit of practice, you will learn a lot of stuff yourself. I mean, nobody taught me all this stuff. I just figured them out by myself, and it works pretty well. You see, so that's the thing. I'll just show you a couple more equations. So. Uh, and you always have these things ready made, but even you don't need them always. You can just try it yourself. It's pretty simple actually. Once you get the hold of it, once you just with a little bit of practice, you can. One thing I wanted to show you is, for instance, you have a plus b. Okay, yeah, whatever, I don't care. Let's say a plus n plus b, and then you have plus something like the plus f of x. So you want to put this thing in bracket. So if you just type in the brackets, it looks very awkward. It looks very bad, as you can see, right? You get what I'm saying, right? It looks very bad. So what you can do in this situation is that you can just select this portion which you want in brackets, and then you go to bracket here, and then you do this. So now you see you get these big brackets, and now it looks very good. If you do this and you do this, then this doesn't work. You see, again, it looks very bad. So you have to do this bracket, or this doesn't work. Okay, and what else? Okay, I'll just look up on the internet some equations to show you some good equations. So for matrix, I mean, the usual way we do in LaTeX. Let me just see if it works or not. I'm not sure if it will work, but let's try. Okay, no, doesn't work. Okay, okay, not a problem. Square root 3 doesn't work. Okay, over, but see, this is, I understand this is a problem with words. So if you just type all this, it's happening, but not on top of the, like, you understand, it's getting displaced a bit. So that doesn't work. Of course, it's not, there is no built-in LaTeX functionality here. It's a bit unfortunate, but that's fine. And what else? It's good. Like, for instance, if you want to do some, let's say, Christoffel symbols. Okay. Uh, for instance, you want to do cap. So that it has capital gamma, right? I'm sorry. So it has this, and then you underscore. Let's say you have this mu nu. So mu, and then you go back here, and then nu. So this is important. You see what I did here. If I do this thing, gamma underscore mu, and I give the space here, it happens. Then underscore nu, I give the space here again, and then I give another space. So you see, okay, it works fine as well. So underscore mu nu, and see on the top, let's say I have something like k. So it works pretty good, as you can see. Let's say you want to write a partial I don't know, I've already covered partial differential, I just want to do something new. Limits, actually most of the under the analysis you are dealing with some very abstract and lesser known mathematical symbols and stuff. I have actually shown you a lot of stuff actually, just for the sake of before we end the video, I'll let me show you some complex symbols as well, and how to you can easily do it. It's like maybe an equation which contains a lot of symbols, if you know what I mean. uh, okay, give me a second please. I don't know, let's say you want to type path integral or something. No, you're not that. Okay, cool. Mm-hmm. This is so confusing. I don't know what to. Okay, cool. So Schrodinger's equation. What else? What equation can I show you? I mean, of course, I don't want to show you like E equals mc squared. That would be too simple. But like, where are my equations? Let's say maybe partition function. I mean, see, I've already showed you. So for instance, if you want to type something like e to the power, let's say minus, oh no, let's just say beta e underscore I something. I'm just typing it at random, divided by something like some blah blah blah, whatever. So all of these things you can take care of. Most of the equations in for like most of the general common equations we deal with, you can actually take care of if you just follow whatever I showed you. More than sufficient actually for that purpose. Okay, and like if I could just show you some a lot of symbols, and maybe just if you could suggest me an equation which contains a lot of symbols, like we could just try random like nonsense stuff. For instance, this is nu, this is mu, this is theta, this is sigma, this is lambda, this is okay, this is I don't know, this is alpha, this is beta, this is gamma. So it all works. You see, it all works. It's not difficult. Oh, okay, let's say we want to type something like yeah, this is a good one. This is Fourier. So let's say we want to type something like okay, f of x equals to a naught. This is a naught. This is fine. Plus, okay, you again want a sigma, so sigma underscore n equals to 1. So you see what I did here? I did sigma underscore n and give the space bar. So I created the subscript, then I went back to the subscript and then wrote equal to 1 and then over superscript n. Okay, and then you want these brackets and you want to write a n cos cos something like 2 pi. For pi it's yeah, this just backslash pi 2 pi n x over let's say p. So you can keep it like this. If you want the equation in a single line, it looks very good. Otherwise, if you just do this, you can create create it in this form also. Plus let's say b n's sine this thing again right over here, pi nx. Okay, 2 pi. After write pi, just don't type something immediately, just give the space, so generate this pi. Otherwise it will be 2 pi nx would look like this, which would look bad. And then it would the pi would not be rendered. So you just once you type this, you just give a space. Okay, and now you write nx over p. But now you see it looks very bad. So what you're gonna do is you're just gonna rub this just remove this braces and just do this manually. And for this also you can just do it this manually. Second bracket, or if you would prefer then maybe third bracket, whatever works. Oh, I'm sorry. uh, So you see, this is just for just to show you. No, I'm not saying that this is a very, like, there are problems, and in many situations using LaTeX is better, is a better option, but there are some things cannot this cannot deal with. What cannot deal with? Well, let's try a chemical equation actually. Simple one. 6CO2 plus 6H underscore 2 O. Just keep the caps lock on for chemical equations. Okay, and then right arrow, so just do hyphen and then give the greater than symbol. It automatically happens. C6 space. See, this is important. You want to write C6H12O6. So don't give be like C underscore 6 and then H. No, don't do this immediately. Then it will not be rendered. Once you have this, you just give the space. Okay, now you move on to H12. Now you move on to O6. So see, you have it there, plus 6O2. 6O2. There we have a pretty little chemical equation. You want to do SO4 2 minus. Okay, this is a bit interesting. SO underscore 4 over score. So okay, again underscore 4, give a space, over score 2 minus 2 minus. Okay, this doesn't work. And if you don't want this italicized, just press Control plus I to turn it off. So now you see, you're not getting italics, you're getting the straight ones. Here it's italics. You can turn it off if you want. If you just do Control plus I, of course, it's not italicized. So SO. So you have a in the subscript you have a 4, and in the superscript you have a 2 minus. So 4 space, and then you have 2 minus. So just do this first and give the space. And now go back there and then put the minus. Otherwise, I mean, this works, right? Plus BA2 plus. So BA in the sorry, I'm sorry. You have 2 plus. So don't do this. Otherwise, it will be like this. Just do BA. Okay, first let's just turn off the italics. BA 2 and give the space, and then go back there and type plus. So BA2 plus. This gives you BASO4, right? Yeah. So BA. Okay. Again, BASO underscore 4. This is what equation is this? Okay, I think this is. I don't. Why don't I recognize this equation? This look. Okay, I'm sorry. This is Navier-Stokes. Yeah, this is a good idea. Let's try Navier-Stokes equation. Wow, this is good. So, first of all, it's a partial time derivative. Okay, I'm sorry. First of all, you need to do alt plus this. Okay, then partial time derivative. So partial v, partial. Okay, partial. Give the space first, render the symbol, and then you type u or v depending on what how you are denoting your velocity field. So I'll go with u. You can also go with v. Then again underscore partial t. I'm sorry, I forgot that. And you give the space. Who is this? I'll just put my phone on silent for a moment. Just hold on. Okay, this can wait. So and in some textbooks they use the notation like this. Let me show you. Partial underscore t u. So this is the same thing as, let's say you want to write equivalent. So we often write this way three, like this is equal to and this is equivalent symbol. You can see in the symbols. You can do this, but you just also can type it in backslash EQUIV equiv and just give the space. So this is equivalent. So writing partial underscore tu is the same thing as writing partial u divided by partial t. The same thing. So this just means the time partial time derivative of u. So anyway, let's just focus on the Navier-Stokes equation first. Okay. So you have this, and what else you have is you have okay, you have this convective term. So it's like u dot. This is the grad symbol. So nabla symbol, actually the grad doesn't work. I mean, the symbol is, this is actually gradient, but you just need to type nabla, and then you have another u here. So this is equal to your viscous term. Okay, first of all you have negative 1 over rho, where rho is your, I think, the density, right? And then you have the gradient of, I'm sorry, you have to write nabla, but this is the gradient of pressure. So nabla p, where p is the pressure. Plus you have gravity, plus you have the viscous term where let's say you have this thing called nu, which is your kinematic viscosity. It's just the viscous coefficient you have it, nu is just eta over rho. So you can also write eta over rho just for practice. So eta over rho. Okay, this doesn't work. Yeah, eta over rho. So eta over rho is just actually your nu, and then you have this Laplacian, so which is just nabla squared. This is the equation. Now I don't want to start talking about fluid dynamics here, fluid mechanics, hydrodynamics. But this is the thing. So this is the convective term, which is balanced by the viscous term here. And these are the other this other stuff. They're the standard terms. So for instance, if you have a stationary flow, then this term will go away. In many cases, you can ignore the gravity and blah blah blah. Anyway, so usually it's a very complex equation. You see, this equation is non-linear. You know why? Not because of this term. This is a double derivative with respect to space, the Laplacian. So you see, this equation has a double derivative with respect to space and a single derivative with respect to time. So under some circumstances, when you can ignore the other terms, this equation is just like a diffusion equation. Schrodinger's equation is also, if you look at it, it's a double derivative in space and a single derivative in time. But the thing is that this term is the convective term, and this term is what makes the equation non-linear. Because you see, let me just type out what is this thing called. For instance, this nabla. Actually, do you know what this is? This operator. This is actually partial over partial x. So in space, this is a space term, right? So in three dimensions, this is this thing I cap. Okay, I don't know how to write I cap. You have to use the accent here. Okay, so this is I cap, right? Now I'm not sure how to do this. Okay, I'll just try something else. Maybe I cap. Of course not. This doesn't work. At this works, but how to put the I there, like just below this? I don't know how to do this. See, it's getting displaced. That's the problem actually, and you cannot do this, right? If you want to bring the I here, yeah. So anyway, for this for few things you can just use this ready-made this directly. Plus, so yeah, since you have already written this, you can just copy paste this. Just Control plus C and you just paste it twice. So this is actually supposed to be del y. So just del y, and this is supposed to be j plus this is supposed to be del z. Oh, I'm sorry. This is supposed to be k, right? So let's say what is u? U is the velocity field. So let's say u is ux I cap. So again for I cap, it's better use this right over here, plus uy j cap plus uz space, and then you have this k cap. So that means you the dot product u dot the gradient would be. So what would be the dot product? Tell me. So since you have written, suppose when you if you're typing this in an actual document, you don't need to write everything. You have already written. Just copy paste. Just copy paste. Plus, okay, just do this. Just do this, so it will be easier. There will be a plus here, and you just manually just correct this. So this is y, and this is not y. So the thing about Word is that once you have generated the basic structure, like for instance u and there is a subscript, even if you press backspace, the structure remains, and you can just modify it. So these are the stuff which you can do actually. So which is why this is a scalar dot product. But for instance, this term, if you want to write this term, so the pressure would also be this thing, right? So it's pressure is a vector, so it's p x I cap plus py j cap plus pz k cap. But now we have this thing. So we have just this, the gradient of pressure. So this is actually like a divergence, but this is the grade. So if it is the gradient of pressure, then you see you cannot ignore this term. So it's still a vector. So then you will have this thing, right? I'm sorry. So then you will have del x px I cap. Okay, so you have sorry p here. here, and you can just do this. And you have J cap here, so make it J cap, and you have P, you have K cap here, make it K cap. So yeah, this is it. This is you have it. Or if you would prefer it here, so you can just do this as well. Just do this. Yeah, I think this actually looks better. So so just this was a good example. Navier-Stokes equation. Anything else that I can think of or that I can see on my okay? I don't know what to show you next, if I'm being very honest. But let's see. I mean, I think we should stop here because it's anyway a pretty long video, and I already showed you the stuff you'll be needing for dealing with most equations, and you can always look up. So, for instance, you're typing a document and you're not sure how to do this. You can always look up on the internet on ChatGPT or something. The point of this video was to just introduce you and give you a rough idea, which I think I did. So, okay, thanks for watching. I think I'll stop here.